Welcome to a new test and teardown video. This time it's a follow-up on my green laser video. I have been writing quite a lot with a laser expert from YouTube called Lodon. His name is Patrick, and he's super into lasers and stuff, and got a really good video channel about lasers, repairs, and all sorts of stuff about lasers. And he got exactly the same laser unit as I got right here, but his is working. And he spent quite a lot of time looking at the different parts and how it's working and all that kind of stuff. And he sent me a lot of documentation, including schematics of this board down here. And we can now see the different parts of protection diodes and how the control boards interface, the different sensors, the temperature sensor, the heater, and the temperature heater on the crystal, and the output sensors, and all that kind of stuff. And he gave me quite a lot of information. I think we should try and add a little bit of this in this little follow-up video. For example, we have now learned what all this is, how it works, and what it's all about. So let's look a little bit. We got the heater and we got solder. So the idea is this little glass part we have down here. I think it's some sort of a special crystal or some special glass component. But the thing is, it's supposed to isolate so the heater can heat up the solder. And while the solder is liquid, you use a micro manipulator or nano manipulator, whatever it is called, to grab onto the glass, or maybe you grab onto this white ceramics, and then you heat up, you make the solder liquid, and then you move the mirror onto perfect position. And then when you cool this down, it will stay exactly where you have calibrated. And that is how you do it. He also said a lot of information about the resonant parts of the circuit and how I can get this working, or at least figure out what is wrong. So the suggested is that I crank this up to 15 amps. And if I don't see any green output, then try and push carefully on the mounts, just down here on the metal, because pushing just slightly there will move everything here in the nanometer range, and then we're hopefully going to see a little bit of green. This proves it's all an alignment problem. So what I've done here, I put some paper on the output. I will put a piece of paper on the top here so we can't see anything here, because I don't want any reflections to make me blind. But I will try and focus on the paper, and hopefully we're gonna see a little green dot. Now the camera is fixed. We'll turn off the light. We'll crank on the power supply, and I'll get a screwdriver. And then I will slowly crank up the diode current to 15 amps. You can probably see this is the infrared you see here. I'll have to do, whoops, I have to put paper here. I'm sorry about that, because I am right here and I don't want this to shine into my face. So let's go to 15. And remember, this is the paper for the output, okay? So now I push gently on the output on the right side. And I don't see anything. Then I push on the... I think it was also this one I should push. We don't see anything. And look what we got here. Can you see a green laser output right there? And if I push it, I don't know if that is easy to see, but it actually gets brighter when I push over here on the right side. So yeah, we got output. It's quite weak, but it's output. So thank you very much for watching. I will post a few pictures here from my experiments with this laser in where I'm using a special camera that shows the infrared a lot better, so you can see how and why it really looks. And I mean, this also should warn you about poking around with lasers that's using invisual light waves. You can't see this infrared, so it is definitely very, very dangerous. Anyway, thank you very much for watching. I hope you had a little bit of fun, and I will put a link in the description to Patrick's YouTube channel. And thank you very much, Patrick, for helping me. That was so much fun learning a lot more about lasers.